Hello students, and we're going to be taking a look at more problems involving right triangles. So this time we're starting off with a triangle, but it's not a right triangle, so we're going to have to create one. So we've got triangle PQR, and we're asked to find what angle P, angle Q, and angle R are. So let's take a look. What kind of triangle is this? Well, this is an isosceles triangle because two of the legs are the same. 12 and 12 are equal. So we're going to use a property called the isosceles triangle bisector theorem. So what it says is from your central angle, that's the one that's spanned by the two equal sides, you can drop down a 90-degree angle. So let's take a look at what that looks like. Now, when we drop down this 90-degree angle, it does something special. What it does is it cuts this base into two equal pieces. So if this whole thing was 18, this section here is going to be 9, and this section here is going to be 9. So notice now that we've got two right-angled triangles. So I can break this up into two different right-angled triangles. So I'm going to call this P1 and R and P2 and Q. So first off, well, angle R and angle Q have the exact same measure here, but if I'm looking for angle P is equal to angle P1 plus angle P2. Now the nice thing is that these two triangles are congruent, meaning that they're exactly the same. So another way to take a look at this bisector theorem is that this line here not only bisects the base, but also this angle here must equal this angle here. So really, all we have to do is solve one of these triangles, because angle P1 is equal to angle P2, so this is the same as 2 times the angle of P1. And similarly, because this is an isosceles triangle, angle R is equal to angle Q. So we've simplified our problem quite a bit. So I'm going to stick with this triangle here on the left. So what we want to do is we want to name the sides with respect to Q. So let's take a look at what we're going to get. So we find that with respect to Q, we have opposite, adjacent, and hypotenuse. So let's take a look at our SOHCAHTOA. Notice that the sides that we know are our adjacent and our hypotenuse. So which function are we going to be using? Well, we're going to be using cosine. And again, because we're looking for an angle, we're going to be using the inverse cos. So the inverse cosine of adjacent over hypotenuse is going to give us our angle Q. So in this case, adjacent is 9, hypotenuse is 12. So we have 9 over 12 is going to equal our angle Q. So let's punch this into our calculator and see what we get. So we find that to the nearest degree, we get Q is equal to 41 degrees. So we can use a bit of a trick here. Notice that because this is a right triangle, we want to find out what P1 is. Now, it's very true that we could go through the whole process again using, for instance, sine. So, but instead, let's use the fact that angles in a triangle add to 180 degrees. So if I'm looking for what P1 is equal to, well, all I have to do is take 90 degrees and take away angle Q. So in this case, our P1 angle is going to be equal to 90 minus 41. Whoops, sorry, almost gave it away there. 90 minus 41, and what we get is 49 degrees. So we were looking for, in the end, angle P. Well, angle P, we said, was 2 times angle P1. So this is 2 times 49 degrees, and that equals a total of 98 degrees.